Last time we started trigonometric integral. The pattern of the functions we studied had odd degree power. Today we will consider the function which has even degree power. When that happens, without odd degree power, when that happens, what you will use will be half angle formula. Could you please turn on your webcam? In that case, we will use half angle formula. Those are the formula you have to remember. Evaluate integration 0 to pi sine squared of x dx. If you see the integration, then you see only sine squared. So you cannot use substitution method. So the idea is by using this half angle formula, we will lower the degree and then we will be able to integrate. Integration 0 to pi sine squared of x dx equals integration 0 to pi. We are using this formula. Then that is 1 over 2, 1 minus cosine of 2x dx. So that is 1 over 2 integration 0 to pi 1 minus cosine of 2x dx. So we can do term by term integration. So 1 over 2. So if you integrate 1, then that becomes x minus. If you integrate cosine, then you will get sine. So that is sine of 2x, but if a number is multiplied to x, then we have to divide by. Indeed, that can be obtained by using substitution method, but we will not go through all the details. So 0 to pi. So we plug in, then 1/2 pi minus 0 minus 1/2. So we just write that in front of parenthesis. Sine of 2 pi minus sine of 0. This is y equals a sine of x. So this is 0, and then the next one is pi, the next one is 2 pi, and so on. So the sine value at 2 pi and 0, or sine 0, will be 0. And the final conclusion is pi over 2. The next problem is also similar problem, but that is a higher degrees, higher even degree. So sine to the fourth power x dx. So we think about integration sine to the fourth power x dx. Then that is sine squared of x squared dx. And then that is, we again use the half angle formula, then that is 1/2, 1 minus cosine of 2x squared dx. Let's just go through all the basic steps. Those are just a squared of something. So 1/2 squared times 1 minus cosine of 2x squared dx. So this one becomes 1/4. And then to expand this part, we will use a minus b squared equals a squared minus 2ab plus b squared, or you can use FOIL. So 1/4 integration. So the first one squared, so 1 squared minus 2 times first one, which is 1, times the second one is cosine of 2x plus the second terms squared, so cosine squared 2x dx. So what's happening here is definitely first and second term can be integrated. But for third term, cosine squared of 2x, we have to lower the degree again to integrate by using half angle formula. This time we will use half angle formula for cosine. So we know cosine squared of x is 1/2, open parenthesis, 1 plus cosine of 2x. So if we think about cosine squared of 2x, then we have to double the angle for this part. So 1/2 times 1 plus cosine of 4x, because that is double of that. Keeping this in mind, this one becomes 1/4 integration. The first one is 1 minus the second part is 2 cosine of 2x plus, for this part is 1/2, 1 plus cosine of 4x dx. So that equals 1/4 integration 1 minus 2 times cosine of 2x plus 1/2 plus 1/2 cosine of 4x dx. So that is 1/4. And then we will just do term by term integration. The first one is x minus 2 times cosine of 2x, but we have to divide by the number multiplied to x, so divide by 2 plus 1 over 2 x plus 1 over 2 cosine of 4x. This time we have to divide by 4 plus c. So we add these together, then 1 plus 1 over 2 is of course 2 over 2 plus 1 over 2, which is 3 over 2. So that becomes 1/4, 3 over 2x minus, these two will cancel each other, and the cosine of 2x plus, we multiply these two together, then that is cosine of 4x over 8 plus c. Do you have any question, or can I move on? Evaluate integration tangent 6 power x times a secant 4th power x dx. As you can see, both are even degree powers. So we have to set the strategy. When we think about the tangent and cotangent, tangent and secant, what you know is the tangent of x dx is a secant squared of x, right? That is the first thing you have to think about. And other important trigonometric identity is Pythagorean identity, which is 1 plus tangent squared of x equals secant squared of x. So the way we will see the given expression, tangent 6 power times secant 4th power dx will be integration the tangent 6th power x times, we have secant squared of x times secant squared of x dx. Then what will happen will be this part can be regarded as the tangent of x, right? Moreover, for the left side, for these two term factors can be converted into tangent related expression. So secant squared can be rewritten as 1 plus tangent squared. And then this part will be tangent related expression. And if we differentiate tangent, then secant squared will be obtained. That means we can use the substitution. So integration tangent to the sixth power x times, instead of secant squared, we will write 1 plus tangent square root of x and secant square root of x dx. So obvious choice will be u becomes tangent of x and du becomes secant square root of x dx. So that equals integration u to the sixth power 1 plus u squared. This part is du. So this one is integration u to the sixth power plus u to the eighth power du. And then we integrate term by term. Then that is u to the seventh power over 7 plus u to the ninth power over 9 plus c. And then the important step is we will have to replace u by tangent. So 1 over 7 tangent to the 7th power x plus 1 over 9 tangent to the 9th power x plus c. Any question? There are many formulas which came from the previous course. This is trigonometric identity, the Pythagorean identity, which you should remember. The next question is find integration tangent to the fifth power theta times secant to the seventh power theta d theta. This time, this is not the even degree power, but what you realized should be when you differentiate secant of theta, you are getting secant of theta times tangent of theta, right? And then after you remove tangent and secant from each factor, you have tangent to the fourth power and secant to the sixth power. Both are even degree power. So what you can think about is you can change it to one type, either secant or tangent. To do that, we will use Pythagorean identity again. Tangent square root of theta plus 1 times secant square root of theta. Let's say tangent of fifth power theta times secant to the seventh power d theta. Then that is tangent to the fourth power theta times secant to the sixth power theta times tangent of theta times a secant of theta d theta, right? For this part, that is d secant of theta, right? So obviously we have to convert the equation into secant related thing. So from here, we will fix the equation by subtracting 1 on both sides. Then that is tangent square root of theta equals secant square root of theta minus 1. Right. And then integration, tangent fourth power theta is tangent square root of theta squared times a secant sixth power theta times tangent of theta times secant of theta d theta, right? So integration tangent squared is a secant square root of theta minus 1 squared secant sixth power theta times tangent theta secant theta d theta. So this part is completely secant related part. For this part is the secant of theta. So obviously we have to think about the substitution, which uses secant. We will put u equals secant of theta, then du equals tangent of theta times secant of theta du d theta. Let's do the substitution. Instead of secant, we will use u. So integration u squared minus 1 squared times u to the sixth power times du. So a minus b squared equals a squared minus 2ab plus b squared. So that means integration u to the fourth power minus 2u squared times 1. I don't have to write it down. And 1 squared times u to the sixth power du. So we will do distribution and then integration u to the 10 power minus 2 times u to the 8 power plus u to the 6 power du. Of course, you multiply. Let me write down the formula a to the m power and a to the n power. Then that is a to the n plus m power. So that is u to the 11th power over 11 minus 2 times u to the 9th power over 9 plus u to the 7th power over 7 plus c. So what is u? U is secant. So secant to the 11th power theta over 11 minus 2 over 9 secant to the 9th power theta plus secant to the 7th power theta over 7 plus c. Any question? If you look at one by one and just follow through it, none of them are very hard. But the problem is there are so many patterns. And if you don't remember how to approach the problem, then you will be confused during the class, the exam hour. And exam is only 50 minutes. So it'll damage your exam score. So always remember, keep in mind that not only understand something, but also remember things is important. So what is the last page? I think it was this one, right? Oh, it is not? No, I don't think this is the this one. So are you okay? Okay, and then let's move on to the next subject. So I want to summarize the strategy for evaluating integration tangent to the n power x times secant to the n power dx. If the power of secant is even, then you have to use secant squared of x equals 1 plus tangent squared of x, and we will put u equals tangent of x, and du equals secant squared of x dx. So integration tangent to the n power x times secant to the n power x dx equals integration tangent to the n power x times secant squared x times n minus 2 power times secant squared of x dx, right? And then this part is du, and this one can be converted into secant related, this part can be converted into tangent related equation. If the power of tangent is odd, then we have to use tangent squared of x equals secant squared of x minus 1, and u equals secant of x, and du equals secant x tangent x dx. So what happens here will be tangent of n power x secant of n power x dx will be written as integration tangent of m minus 1 times secant of n minus 1x times tangent of x times secant of x dx. But for this part, that can be written as du, right? And u was secant, so we will convert this part to secant related expression. There are some formulas which you have to remember, or you can derive indeed. The for tangent is sine over cosine, so that is natural log of absolute value of secant of x plus c. And another formula, which is a little bit harder, is secant of x dx. Then its integration is natural log of absolute value of secant of x plus tangent of x plus c. We will use the formula when we solve the problem. Let's do the problem. Find integration tangent cubed x dx. From here, what we can think about is if we differentiate tangent, then tangent will be secant squared of x dx, right? But secant squared x can be written as 1 plus tangent squared of x. So what we realized from here is tangent squared of x equals secant squared of x minus 1. So when we break tangent cubed of x dx into two parts, we can rewrite that as tangent of x times tangent squared of x dx. So that equals integration. Tangent of x times tangent squared is secant squared minus 1 dx. So we do distribution. Then tangent of x times secant squared of x dx minus integration tangent of x dx. We already discussed the integration of this part. You can obtain it by doing a simple substitution by writing tangent into sine over cosine. For this part, we did this. So when we differentiate tangent, we get secant squared. So we can use substitution. So u will be tangent of x and then du equals secant squared of x dx. So this part can be written as integration u times du minus the next part can be written as natural log of absolute value of secant of x plus c. So when we integrate, that becomes u squared over 2 minus natural log of absolute value of secant of x plus c. U was tangent, so that is tangent squared of x over 2 minus natural log of absolute value of secant of x plus c. Any question? If you have question, then you can ask me, and otherwise you can leave.